Alright, so we're going to talk about how are different ways that you can force a equilibrium reaction either back to the reactants or forward to the products. If you want to think about it on a macro scale, if you've got like a limit of how many shoppers can be in the mall, then one person has to leave while another person comes in. You still have the same number in the mall, but you have different people involved. Same kinds of concepts if you have cars on an island. There's so many cars that could fit on the island, so 10 cars have to leave while 10 cars come in order to maintain the same number. It's just different things involved. That's what equilibrium is. On the macro level, you still have the same amount contributing to a system, and the system being a reaction, but you have different things, not the same atoms involved or molecules involved in it. And there are different ways in order to affect equilibrium, and this is a definition of Chatlier Principle right there. But what happens is we have, you can change your concentration and your temperature. If you increase either of those, it's going to shift, and I say it, meaning the reaction, is going to shift to the opposite side. So if you're adding to if you're adding an increase in concentration of a reactant, then it's going to shift to make more of a product. If you're increasing the temperature and it happens to be on the product side, it's going to shift to the reactant side, and we'll do an example in just a moment. So if we shift to the opposite side of what you're adding to, if you decrease that, it's going to shift to the same side of the reaction. Okay, with pressure, if you increase the pressure, it's going to go to the least number of gas moles. Or molecules, however you want to look at a reaction. So obviously if it increases, then if it decreases, if you decrease your pressure, it's going to go to the side with more gas moles. And pressure, how many they are based on the coefficients, adding the sides together and everything else. If you have a true solid, a true liquid, or an inert gas, which is your noble gases, then adding them to a reaction does absolutely nothing to the reaction. So let's do a practice problem together. Okay, so we're going to figure out what happens when we have solid carbon reacting with water gas and heat, making carbon monoxide and hydrogen gas. Well, if we lower the temperature, meaning we're decreasing our temperature, then it's going to shift to the left, or your reactant side, it being the reaction. Because you're taking away temperature, it's going to the reaction will go back to replace what you've taken away. In order to maintain that ratio, remember that your products over your reactant, so it has to maintain that ratio. So it has to replace it. If you increase your pressure, you see that you have one gas molecule here, and you have 1 plus 1, so you've got 2 gas molecules here and 1 here. So if you're increasing your pressure, it's going to go to the side with the least number of gas moles, or molecules, however you want to look at it. So that means it's also going to go to the left, replacing your reactants. It's got to, when it comes to pressure, you've got less space involved, because if you're increasing your pressure, you're decreasing the volume. And so it wants to have the least resistance against the volume that you have involved. Okay, if we are removing our hydrogen, meaning we are decreasing hydrogen, it's going away. So you're taking hydrogen out of the reaction. Well, what happens is the reaction has to replace that hydrogen that has been lost. Therefore, it's going to shift to the right, it being the reaction, the chemical equation, reaction, what's going on, that's an R. So if it's shifting to the right, that means it's going towards your products. And the opposite is true, that if we add more hydrogens, or adding to it, then what's going to happen is it's got to shift to the left, which is your reactant side. because as you add to your numerator, you've got to create more denominator, thinking back to those equilibrium problems. That's reactants. I don't know why this pen thing is messing up today. That's reactants. Adding neon. Neon is a what kind of element? It is a noble gas. Therefore, nothing happens. Let me pick a better pen color there. So nothing happens here. Guess pen color didn't matter. It's just wanting to mess up. So, if you add temperature or concentration of something, then it shifts to the opposite side of where you're adding to, it being your chemical reaction. If you take away, it's got to shift to the side that you're taking away from. If you're increasing your pressure, it goes to the side with the least number of moles, and increasing pressure means you're decreasing your volume. If you decrease the pressure, meaning you're increasing your volume, then it goes to the side with more, because you can have more molecules bouncing against those walls of the container of what you're dealing with. And then again, if you add a solid, liquid, or inert gas, meaning noble gas, then you will have actually no effect on the reaction whatsoever. It'll just maintain whatever equilibrium state it was in.